Does everyone hear me? Yes?
Yes, please. Go ahead.
Right. First of all, apologies for this long delay, really out of my control, but thank you for your patience. And thank you also for Dr. Tamer to invite me to have this conversation. I don't think it's going to be a very formal sort of discussion, but I'll try to be very very detailed insofar as some of the matters concerned. So my name is Fernando Vieira, as per the presentation of my bio right now by Dr. Tamer. And yes, I've been in the kingdom for the past 7 months, working with Mahadan in innovation. But now at the moment I'm not, so I'm doing my own sort of advisory activities at the moment. So in that capacity, I am here. Some of the material here presented, particularly the use cases and the examples I will give towards the end, are from a research center that I worked for as program director. I wish you to have a view of certain of the things that can be used and exemplified for us to maybe mimic or have examples of here in the kingdom too. And so bear with me, some of the stuff it's probably not directly understood, but mining is a new activity here in not a new activity altogether, but a concept of engagement for R&D in the kingdom. So I'll try to give some ideas. I will not profess to know everything, of course, and I'm always learning. But the purpose of this conversation today is essentially to share some of my experiences and my considerations that I have done so far. And of course, understanding it, some may be even misguided, but it's what I understood being certain other requirements in our. And so here we go. Let me just always remind people of what some concepts about responding innovation and understanding some terminology. And as we deal with R&D and R&D leads to innovation, it's quite interesting that we recapitalize some of these concepts. So yes, we all start with a good idea, and particularly having a good idea, show possibility is an invention for eventually of something that we want to invent. And that innovation is turning that idea into some kind of a solution, right? A solution that eventually add value to some entity, some person, some company. But then there's another concept, and we often forget in centers of excellence and R&D centers, is the aspect of implementation that we need to consider. And that involves the commercialization of that invention. The examples I'll show towards the end of the presentation later on. And so also another concept that we need to bring about is this concept of technology readiness levels. There's different scales of it. They mean some things for different people, but essentially they kind of exemplify also that journey from the invention through to the implementation, at which stage you got a readiness of it. Somewhere in the invention, there is elements of research and development. So, and sometimes even during implementation, we revisit R&D yet again. So, but for those that are less familiar with mining has got a number of if you will, phases. We call it, stages of valorization, and we call it also the value chain of mining. Sorry for the short writing, but essentially those little boxes begin explaining how mining goes into a journey through to commercialization. We talk about an area where everything starts with the exploration phase, where we really do drilling on the ground. We kind of define some of the presence of the minerals there. And then we get a lot of data, geoscientific data, that we need to process, for which there will be a lot of R&D to be conducted still in that space. And then we go into discovery, which pretty much gets all the data processed, and we find how the geological model articulates. So there's a definition of the ore body, and that's discovering of the value, if you will, but it's not quite quantifiable yet before we do some just statistics and come up with the definition of pretty much, which is here, definition of grade distributions, material properties of the ore, so we can actually then come up with the planning of its mining and its extraction. And that's that involves fragmentation, the mineral extraction itself, goes through the plant over here, and then crushing and recovery of the minerals, and eventually gets deployed, which is the waste deployment over there. So all these stages, and they are for segments that we don't necessarily need to explain today what they are, but there are segments in each of those categories that in each of them there will be elements of R&D, elements of innovation to be pursued. Yeah. So when we talk about mining in general, we're talking about all these phases, but quite frankly, they are actually segmented. We normally talk about in exploration activities, kind of discovery activities, definition of the resource, and then the concept of mineral resource and mineral reserve are probably a subject for another discussion. They don't mean the same thing, and they all in this space. When we talk about then planning and definition of value, technical economic assessments is in this space over here, and so forth we go. So when in the slides I will present later and discussing some concepts, when I talk about mining, I talk about all these sort of composites of stages of the value chain of mining. So that leads me now to consider mining in the kingdom. So, right, there's a lot to be said, and I will not be able to say everything and to encapsulate all what's going on in mining in Saudi Arabia, right? But there's one thing that we need to be aware of late of the last, if you will, decade and more prevalent in the last 5 to 10 years, which is this pressure for the energy transitions around the world. And so there's reshaping totally, in fact, the minerals industry altogether around the world. There's a huge demand for minerals, and this in all geopolitical jurisdictions. And then, in fact, there is an estimate by 2050 there'll be 13 to 25-fold increase in demand, pretty much of all the critical minerals. And that can sound very good. There's a lot of hype for that, but causes a lot of anxiety as well, because we're not ready for that. And I'll tell you some of the reasons why I'm not. And because this discussion about R&D, part of we're also not ready is actually not ready to setting up programs of research and development that support, in fact, the quest for these demands and the technologies that are required. And if you really have a look, just very briefly, in some sources that are listed below, these, at least critical minerals of many, copper, cobalt, graphite, lithium, and neodymium and others, and rare earth and nickel, they all kind of used in pretty much technologies that are now commonplace, from solar, wind, power grids, electrical vehicles, hydrogen electrolysis, nuclear and hydropower, and different degrees of quantities and volumes. And then, because now the pervasiveness of these technologies now are there and they're growing in demand, therefore there's, it seems, forecast not enough minerals out there, and there's a lot of pressure. And the question arises, what can we do? There's many things that we can do in the whole discovery phases to accelerate exploration. There's a lot of things that can be done to optimize the recovery, to the waste and so forth. I talk about those right now at a bit of a moment. So there are concerns about the critical minerals sort of drives towards in the world, and giving pressures to everywhere. And those challenges are, for example, in the rising in demand. And so In fact, it outspaces the supply, and outspaces in the sense that it's not like going to the supermarket now. There's more clients wanting a particular article and the factory just produces. Not so, because to establish a mine takes years. In fact, takes decades. Particularly, take a block cave mine, always perceived as the modern way of mining, given the ore bodies, of course. That takes about 17 years to come to full production, and anything between $2.5 to $10 billion investment up front. So it's a huge development. So there is a concern that can we do anything to really accelerate that? Could it not? And so there's concern of the timely appearance of these supplies. It's not always that we go to the field and find an ore body. Our techniques that we use in exploration and geophysics, the data processing, the interpretation of the data is still at the pace of very, very slow compared to what's needed. So stuff needs to be done to accelerate these in many dimensions, from sensors, from data analytics, from drilling technologies, etc., etc. Of course, there is of policy as well, and the market's concentration. There are, for example, now a prevalence, everyone is aware that some jurisdictions concentrate notably, for example, China, with the processing of some of these minerals and so forth. And so there is an issue of dependency of those markets and the mercy of that. Some countries like to have independence of supply from just one source, and so there is this pressure as well, I'm sure, in the kingdom here to find ways of how can we sustain, for example, the advent of electrification and the EVs and coming forward, and where we're going to get all those minerals from processed to ready from one supplier. And there's, of course, sovereignty risk in that sense. Of course, there is this issue then to, can we innovate? Can we innovate ways by which, where technologies are applied today, for example, in China to process minerals because they own them. They're actually quite good at doing that. Can we find ways to do so elsewhere? So these critical minerals demands raise a lot of questions even for R&D and innovation. But mining is important. Mining is important for Saudi Arabia, of course, and it's important because the ministry and His Excellency the Minister of Mines have really declared that mining is the third pillar of the economy to become very strong in the coming decades. And so therefore there is a need to develop this industry. But do we have the pace? Do we have the technology? Do we have the people? Do we have the support industries to accelerate that uptake? That's a question we need to answer. And my read so far is no, we don't. There's great efforts from the mining company of the kingdom, Mahadan, I work for, very diligently wanting to accelerate many things. But I think the efforts are insufficient. We need to do more. And what it is that we need to do is a quest, of course. So the mining in Saudi Arabia is kind of having articulated by the minister as well in two phases, if you will, kind of the value chain phases. And the first phase is actually to conduct mining activities as such. Let's go and do geological surveys and do exploration, feasibility studies, improve the mines, process raw materials, present to the world and to the kingdom an activity in mining that is really now consolidated and mature, that we attract investment, attracts other players, and diversify those players to accelerate further economies of scale. And then there is this also an interest from the kingdom's ministry to really do what they call intermediate industries. Is it right to mine the stuff and then sell it as raw materials to elsewhere, to other jurisdictions? Or should we then do, for example, processes internally? We don't have that currently, right? Other than some pre-concentration of some of the ores. And some, of course, phosphate is produced and others more readily, but they still are sold not as a final product. So many of the mine products are sold out as raw materials, and the interesting second phase for the kingdom is to develop these intermediate industries. But that requires, again, developing technologies or importing them, but developing people, developing processes, conducting further ways of optimizing those. And then the transformational industries is, okay, even if we then optimize and get a concentrate and produce now a pure a mineral out of all these and only need to ship it out only the raw materials. What do we do? Can, for example, produce magnets and have an industry of magnets here to then do turbine development. So that's the late phase of transformation industries, which I think need to be associated as well in the future. But mining is very volatile. So it's a peculiar characteristic, unlike many other industries, is that it's really market driven. So it's supply and demand matter. It's exposed to risks of sovereignty risks, of environmental risks, sometimes even operational risks that curtail the supply of certain materials, and then the prices go down. And for example, with the recent occurrences of Indonesia that produce nickel at great volumes at a low price, leading many companies in the world to close their operations because they're no longer competitive, and so forth. So there's very sentimental, very market volatility in that space. And so there is also an issue of regulatory requirements requiring, for example, a lot of compliance costs, more and more jurisdictions imposing heavy sort of demands, as they should, on environmental impacts mining is causing, demanding pretty much mining to become more greener and more sustainable, and they're not by far in most jurisdictions, and that's because technology is not there readily available to them. It may be readily available to some of the top tier mining companies that can afford them, but the regular miner, and they're more prevalent around the world, does not have affordability to technology that can make their operations greener. So yeah, there's an issue over there. And of course, there's insufficient expertise and experienced personnel in all jurisdictions around the world. There is not enough mining engineers, for example, and geologists and people related to the minerals being formed today in the world. In fact, many mining degrees have closed and or merged with the mechanical engineering and environmental engineering. So just a little subset. I'm glad to hear and found out that KFUPM, in fact, opened a mining and engineering degree last year, so it's very good. But it takes time. And engineering mining doesn't get formed until 4 years, as most engineers do as well. And so it's going to be a huge demand. If the kingdom wants to progress mining to a great pace, it needs to import also skills, and they're not available out there. So are there innovations you can come up with that can facilitate the formation of experts, as well as the sharing of knowledge, as a thing we need to consider? But the one important thing that is of importance for research as well is depletion of high-grade ore deposits. I mean, we always hear in the spheres of mineral exploration that, oh, this deposit was found, but is low grade, or is very deep, and so forth. My current processes that were optimized for a certain sort of richness, or the amount of mineral per volume or per ton of extracted rock is now very less or lower than before, and the process is inefficient. And to make it efficient now, it becomes uneconomic and so forth. But this is a big issue. How to then produce still at the rates that are demanded. As you've seen, the demand is increasing now with the deposits being of a lower grade. So what technology am I going to develop? And where do I go? Do I go deeper to find higher grades? But deeper in, it's got all these implications of, again, accessing those ore bodies with different methodologies. and so forth. But also low grade means another thing. It's for me to produce the same amount of concentrate, I have to really process more of low grade to have the same output, same yield. Therefore, I generate more waste into the environment, more materials that I don't need to be piled up, more disturbances of the environment out there. So this is a big quest. Yeah. Anyhow, and the upfront cost is all what I've just mentioned. The same mines can take, capital advancements up front, the tune of billions of dollars, and the return on investment became to be paid, not like in oil and gas, that is a bit quicker, but later, 17 years later, which is a bit of a pain. Incidentally, how much time now I have given this? Yeah, because this can be long. But,
No, we started at 9:50.
Okay.
So we may continue until 10:50.
Okay.
So we have another 40 minutes.
Okay, you let me know if, because I can talk forever. So if I think this, but anyhow.
Yeah, I will remind you once.
Okay. All right. That's great. That's great. I'm happy that you're enjoying. But okay, so Saudi Arabia has really made some advancements. From my sort of mere, I just arrived, but I've been reading a little bit about the efforts that the kingdom is putting into mining through the ministry, through the partnerships, through the private companies as well. Has invested, first of all, he's got $2.5 trillion US dollars of mineral resources endowment. That was announced by His Excellency, the Minister at FMF, last FMF, right? That's tremendous. But can we really extract all these value? That's the question. You may or may not, but that's for us to figure out. But we hope so. We hope so that we can bring technology and people and systems and so forth to do so. So, and Saudi Arabia is kind of steer-fasting into changing the regulatory environments for attracting more investment. But investors in mine, particularly mining groups coming to develop mines, they not readily come up without defining really a resource on the ground. If they do find a good deposit, then they readily come. But it's already important that at least the regulatory setup is in place, but it may take time. So the attraction of players has been important and a big drive. I've noted that some of the big companies, BHPs, Rio Tintos, and others, CEOs have been in Riyadh last year and on trying to figure out, what the value is. And I think we still need to do a lot of work in the kingdom to really attract those big investors, particularly in the presentation of great deposits, or what they call tier one deposits of great value, which are hard to come. But there's a great effort in exploration taking place. And as of last year, for example, was reported there was an increase in nearly 680 million SARS and so forth in exploration efforts. Other companies, including Mahadans that I know of, I know the figures, but they're very serious on that space and they're working hard. It also accelerates exploration efforts to then articulate the value proposition for those minerals in the kingdom. And then many some gold discoveries have been announced, and what's interesting in that later last year, there was kind of a comment in the media that the Ministry of Commerce recorded at least 1,292% increase in commercial record of mining and quarrying activities in the kingdom. That's amazing increase from one period of 2015 to 21. I hope that the recent figures say even a more exciting value for that. But how does that paint? Because this presentation about R&D and efforts in R&D. How does it paint all that into R&D investments? Well, I didn't find out, and it's hard to find. Maybe you in CACs know better. We don't have really R&D investment figures published, right? But even from my experiences as what's the word, as director of innovation, I determined that the investments are not really on par to what's needed, right? even in companies that are genuine wanting to do innovation, they really do not putting enough money into the effort of R&D in mining, and that's a problem. That's a big problem. Although there are funds available, that's another sort of question mark for us, is that there are funds available. There are funds that we know from even from, for example, the authorities, the RDI authorities, the PIF funding available. There are some venture capital funding available and other private companies. But the thing is, we're not channeling that funding towards the minerals research and development, and partly because we're not set up to do it, as far as I understand. There's a great drive, in particular CACs, through the programs of that Dr. Tam is trying to implement, and now MIAP trying to drive sort of or channel a lot of efforts into that investment. Despite this, now nearly $5 billion spent, for example, and in innovation in 2022, there's very little or minimal funding for direct to minerals industry. Although the kingdom wants to really portray and invest up to 2.5% of GDP in R&D sector, but not necessarily for mining. That's a tremendous amount. I hope some of that amount comes to mining. Let's work towards it. Yeah. Okay. So enough of the presenting the scene. Let me just talk more directly for our team here at CACs and others interested in R&D in mining. If you were then to channel sort of ideas or areas of research to create programs of work, right? Where would you go for? What would be of interest for CACs, for example, to become developing, or KAUST or KVPM, as all them, and then in universities should channel their efforts? This is my own list, but you can come up with other lists. So I think having, for example, key areas of R&D investments in accelerating the finding of and mining and extracting of minerals. So there's all together in that value chain, but in this, there's a number of projects and programs already known, some of the needs of that are required to be funded for R&D and innovation development, and even trials, because some of the technology is already in place, having proved the concept, at least somehow we need some funding over there to take them forward. But we need to organize the space and the interactions, the partnerships to enable that. Another area that I would actually put my money on in terms of a research developing entity was on footprint reduction. What does that mean? Mines create a lot of sort of expression when they establish. It means in environmental sense that they disturb the surrounding. If it's not in the desert, there's no one there, it's okay. Maybe not okay, because the desert itself has got some biome and some sort of characteristics of environment needs to be protected, of course. But in other regions, mining is actually disruptive in terms of the environment. So footprint means actually the entire area of expression of the layout of the mine, and the deforestation it causes, for example, and the impacts on the aquifers, on the environment and the fauna, etc. It's tremendous. So reducing that impact is what we call about footprint reduction. It's important. It's an area of R&D that involves multidisciplinary sort of type programs. Mining itself, for example, biology, sort of weathering, water and groundwater and hydrology, climate, etc. Many of these, they need to be packed together as programs of work, right? And one that I would forgot to mention is, of course, and tremendously important, is the impact as well to communities, right? So it's all that footprinting reduction areas of research. The new minerals business horizons to me is all these new waves of economies that are developing through the critical minerals sort of drive in the electrification, the EVs, the renewable energies. All that opens up tremendous sort of opportunities for considering using the minerals that have been extracted before in new ways. So can we get different alloys? Can we even combine them with other sort of products? Can we even substitute them? So in these areas, we need to come up with research, and CACS probably should be an institute to really consider that area of new minerals business horizons development programs that consider all these aspects of technology development in the future. And those, of course, there's the enabling sort of R&D capabilities are required, which is on the digital transformation. And that involves all that has to do with sensing, capturing of data, processing data, transmitting data at speeds of light, and applying intelligence to that, right? And do processing in real time, multi sort of dimension computing, cloud computing, and having all that done. That is an important element. But I tend to see this technology tremendously important for any walks of life, and including in mining. But as far as I understand, they are enabling technologies in mining because they're not the ones that will actually allow for the extraction of the minerals, for the processing of the minerals, for the physical aspects, let's say. But they're tremendously important for the optimization, for the intelligence associated, for the optimizing of, for example, discovering activities in exploration and geophysics and so forth. There's all other sort of areas of research that involves social sciences as well as economics and maintainability issues, reliability, productivity, all related in a space that we also have R&D programs developed. So those are key areas that I would consider. I'll talk a bit more about some of them. For example, in respect to the first one that I mentioned, which is discovering new ore bodies with different technologies, a number of things. These can be projects, come up with advanced geophysics, integrating geoscientific data in multiple dimensions, data analytics, and integrating AI in those. There's a lot of AI applications today, for example, to do work that geologists would have to do in the field, such as do core logging and characterization of the log in terms of the mineralogy, in terms of geochemistry of the core, and but they all still, despite the announcements made by some of the vendors that have got this technology, which is 2 TRL levels, quite high, they sure lack the scientific scrutiny, and because they're all proprietary, and there's no one questioning, in fact, the validity of some of these, and not suspecting that they're not truthful. But I think there is a need for really even developing people understanding the use of these technologies and moving them forward and integrating them with other processes. And so that area, I think, we actually talked about it, developing a center here for really integrating of geoscientific. So that's an area that I would like to consider just on the technology discoveries. But of course, you cannot do that alone. There's collaborations to be done and so forth. So let's not delve into this. It encapsulates this slide. You can have it later too with more detail. But it essentially tells all the sort of types of technologies that can accelerate mineral discovery, even using drone-based magnetic surveys, 3D seismic surveys and airborne surveys with different sort of approaches and interpretative models, because there's a lot of numerical interpretation of the scientific data. There's, of course, the new algorithms, new schemes, new computing processes that need to be developed and are developed, but need to be scrutinized and advanced further. So, for example, one technology has been out there already announced, and some companies are coming up with this cosmic ray imaging technology. So this is kind of phenomenal. So could we, for example, from space really interpret what's going on the surface and then subsurface of the Earth to accelerate the interpretation of targets, at least of further detailed exploration. And there's a lot of science behind it. It is a phenomenal technology. But I don't see many of the scientific bodies working on this space other than some startups and now already developed and producing these works. But we need to percolate that into the scientific arena as well. So on one of my lists up above, I was mentioned about this way of making mines a bit more sustainable. That is this concept of sustainable practices in mining is coming to a pressure now in many jurisdictions. And I'm pretty sure the kingdom is also interested in coming up in implementing these practices. And so it all revolves about this concept of circular economy models, right? And by which we pretty much maximize the resource efficiency. We extract as much as we can out of what's getting out of the ground. Nothing is waste. Everything that's getting out of the ground is a product. And then that concept needs to be inculcated in the mining scene, because today mines are designed in this way. I go make a hole, I extract my minerals, I process, okay, I really separate and concentrate them, I purify them, and I reject all the stuff that I need somewhere. And if I pile up somewhere, right, until there's an accident or until I get contamination, I can get acid mine drainage, I get my aquifer all disturbed and so forth. But that sort of mine of the future should actually obviate that. We should not have processes that generate waste. And I think it could even be that we no longer need to make big holes underground. Maybe we can do in-place mining, in situ mining, and what technologies are required, what technologies and leaching processes, if that's the process, we need to do that are not contaminant and are containable, and the contaminant is manageable. All this involves a lot of multidimensional physics and multidimensional considerations of scientific nature, right? So, and all this, these I think we need to do. But one aspect of the zero waste mining concept that was mentioned is now there's tremendous amount of waste out there in the world, because mining has been going on for centuries. And I think the kingdom has got one of the oldest, if not the oldest, mining in the world. It's 3,000 years old, right? Right? It's fantastic. So, but actually, I think it's worthwhile to go and mine the reject of that mine, because it's very high grade, I'm pretty sure. What I'm talking about here is this mine waste needs to be recycled, because it contains a lot of minerals still there, because the processes that we used are substandard or were processes that in the past were not highly efficient. And even if they were efficient today, they only interest in a particular element. For example, gold processing. I'm just interested in gold. I reject everything else, right? And maybe one or two mining companies have got still some of the other components extracted, but the majority will be interested in gold and reject it because it's too hard and too costly, not effective. So we can go back. But here's a thing that a research body could do, like, for example, the Australians are doing through the SMI in the Sustainable Minerals Institute. Funded by the ministry. Maybe if the ministry is listening, they should create that program here in the kingdom right now. We should have a program by which we need to map all the mine rejects in the kingdom today, because they are, in fact, a resource. They can have all sorts of minerals they contain, right? So that's the concept about sustainable practice in mining and mining strategies and so forth. Okay, is another sort of area that we could develop a lot of technologies for. And there's a lot of work, there's a lot of hype in this. Many companies and startups have come up with these concepts. But I don't see great sort of initiatives in carbon capture innovations being driven in most research bodies around the world, partly because it's costly, needs a lot of funding, and there's a lot of interaction with the partners as well that own these processes. Most mining companies in the world have got a process of separation and purifying and in fact treating the minerals later on. There is energy intense, and some of them, in fact, very highly carbon emitters. Now, very little work has been done globally, apart from some companies that sponsor that, but they're very reduced. At the global scale, there is actually not a big effort going on in coming up with mineral processing technologies that do not emit carbon, right? We need to work on that. And we need to work on that for all of them. Is there a new way of extracting minerals that doesn't involve, for example, the current processes? Is a matter of concern. And even then, if we emit, how can we capture it? Can we capture? Is it sustainable to capture? Is it really effective? This storage in underground, is it really a hype, or is it really truthful that we can really capture the carbon there? What work has been done in the kingdom towards it? Maybe we can begin something there. And there's, of course, this issue of implementing hybrid energy systems in mining to reduce also the energy consumption. So I'm sure many of us here haven't been involved in mining, but if I tell you, for example, the nearly 35 to 50% of the operating costs of a mine are all energy costs for the mineral processing. That's how much it is, nearly, take it or leave it, 50% of my cost is actually due to energy, right? And if spending that energy polluting, then I've got actually double whammy, because now I'm actually having to be charged by carbon emissions, right? And we need to work very hard on these aspects. Okay, so research areas, the programs in that area will be fantastic. And that talk's already driving towards these issues that I was alluding, but carbon emitting, reducing energy for emission reductions is one program of work. But specifically, we need to have mineral processing optimization programs. Now, I'm not aware that in the kingdom, correct me if I'm wrong, we have an institute dedicated to do mineral processing other than of course, hydrocarbons in mining. I don't think there is. There are, of course, some labs in the kingdom that I'm familiar since I was in my previous role at MIAP, aware there are some experiments done in some labs about kind of real projects that go on about optimizing extraction of these minerals. But there isn't, if you will, a lab, a national lab that does optimization of mineral processes at all. And maybe it's a consideration in forming a national lab that will be a kind of a dimension to consider. Because there's a lot to be done, even today, on the recovery of minerals from residues. And there are startups doing it all over the world. They all come up with their own processes. They all come up with their own IPs. They all come up with their own sort of lengthy ways of going about. And there's also the problems of validation. They've got sort of internal testings. They don't validate scientifically and so forth. And so we need to come up with ways of mineral process optimization research, but also creating new ways. And in that way, I was mentioned that's coming up with new processes. For example, direct lithium extraction for the extraction of rare earth, in particular, also lithium, for example, is now a prevalent sort of technique, but there are many others. We could actually establish such processes there. KAUST is having that initiative, at least for the extraction of lithium from sort of saline sort of sources, but that can be extended for other minerals too, you know, and why do not actually explore that? We need to work on that. Okay. Of course, can we, for example, extract other stuff from current red muds and phosphogypsum stacks? That could be interesting. Now, mines are not entities that live forever. So, like oil fields, you know, it will die at some point. Although I think the oil fields in Saudi Arabia are very well endowed, and goodness, and they last long years, in fact, decades. But in mining, you can have what they call a life of mine. Can be short. There are life of mines, very, very small mines can last 5 years. Very surface mines, you just go and deal with on turbo. But in general, a mine that is less than 15 years, the investors do not like it too much because it's a huge capital capital up front, unless the ore is high grade to pay it. It will not really be warranted. And that's why, for example, in some jurisdictions, that kind of miner is small deposit, still rich, attracts a lot of artisanal mining, which is unstructured, which is actually more polluting, which is actually, it creates pretty much an image of mining in an unsustainable form that comes from those environments. But mines normally are long-term, anything between 15 to sometimes 90 years, as there are cases like that, the tier 1 deposits. But in general, 30, 40 years, but they will come to an end. And in many mines, there is a register of thousands and thousands of mines that are closed around the world, right? And they are actually a liability. They cause a lot of problems for the environment, for the communities, and then because in the past there was no demand from the regulators to come up with mine closure programs. Now, in today's world, in Saudi codes of approval as well, it's required that a mine cannot be approved without a closure plan, right? But in closure plan, there's a lot of stuff needs to be done, and the closures sometimes of existing mines, they now have got a fund dedicated for them that actually substantiated and probably used later on. The majority of mines today still out there don't have that, don't have any resources. They are contaminating. So there's a lot of research that needs to be done to engage people, institutes, and to cause, and even governments to then create programs and solutions for mine closure. And I'm pretty sure the Kingdom will be needing that too as well. And so there's a number of areas, for example, in R&D, that waste reduction, mine rehabilitation, land use and transitions, can we reuse the land for other things, etc. Programs of areas that we could create in R&Ds. Okay. All that impacting, of course, in the socio-economic and environmental value, those innovations that we talk about in many ways, and they all explain, and we don't need to go into detail to this. So now, okay, I talked about a lot. So what can we really, if you ask me, okay, you talked a lot about these ideas, but what concretely, what can we put in place? Can we have kind of a roadmap, or can we come up with strategies to begin articulating, establishing R&D areas in the Kingdom? So yeah, well, not everything here, because we could be endlessly detailed, but I'll just give you some tips here. For example, yes, we need to begin establishing these R&D and technology development centers. I think MIAP, for example, is a vision for that, created grant centers. But MIAP is the park of all these centers, but the centers still need to be established. So, and I would articulate that the centers can be established by institutes, by mining companies, by governments, all together working in partnerships, but they need to be established. So, and then they need to come up with programs of work that are collaborative. So coming up with collaborative arrangements for these centers. And they have a number of objectives, including, most importantly, to also develop capability and people in the Kingdom. And I just give a list, for example, of areas of thirst, areas we get questions, whatever, they would need to collaborate in a joint program of work or thirst area, where to establish the first space. In some university or center research could be focused, for example, on the chemistry of it, others on physics of it, others on the numerical and sort of simulation aspects of it, and so forth. They actually attract to them their core capabilities to then come up with cohesive programs. So I just gave ideas of sort of 4 areas that are pretty much aligned with also some of the key priorities for the Kingdom in mineral acceleration. These are the mineral acceleration discovered, all to do with the geophysics, the speed at which we actually declare reserves and out of resources, and so forth. A lot of scientific body of work needs to be done, and the low emissions and the energy sort of areas, it'll be important. So these, okay, take for example, I would go about to establish, I'll give just example for one, the first area one, which is invest in R&D and mine waste recycling. Okay, the argument is we're going to create a circular economy strategy. We're going to adopt sustainable practice in the kingdom. We're going to involve public and private partnerships. So there will be kind of a cohort of the investment from these entities, and then we will do a non-conventional study of technologies, and so the scopes of work, the programs of work will be kind of articulated by an advisory body of the various partners that participate, and that will be kind of a consorted national efforts for this particular mine waste recycling activity. Yeah. So, okay, how do we go about build the capacity in competent in resources industry? So, I would say we need to begin investing in state-of-the-art facilities. I know, for example, some universities have got tremendous facilities, the ones I visited at least, and but they do not seem to have focused programs specifically for mining, right? So the state-of-the-art facilities I mean is having not only the physical space, but having also the laboratory facilities there, the equipment, and of course the researchers, right? And then the definition of those programs. Begin with that. So I think ACS is interested in coming up with those centers of excellence together with the industry. And I hope to articulate also that need for other knowledge centers around the kingdom, more closer to the ideas of this. Okay, so, and then one thing we need to develop is these collaborative programs. So one entity cannot develop all the technologies needed. We need to establish sort of grand schemes of collaboration with the various partners. And then we have to definitely find the streams to articulate the financial incentives and the grants for substantiating these efforts, right? And so the funding could have, of course, the various traditional fundings, could have venture capital sort of type fundings entering, could have established the universities within the CACST, if you will, hybrid entities that will be destined to commercialize the R&D and the innovations that come through. Some universities that I've visited already have that. Others are still in formation of that capability. But all these need to work together to then enable in mining and those programs that I've listed. But I think what we need to also do at some point, pretty quick, I suppose, although there's a lot of articulation from the various centers I've been dealing with, there isn't a cohesive and consorted and maybe integration for mining R&D. So I would suggest there could be a white paper or to be written about what is R&D and the requirements for in the kingdom and the innovation requirements. Everyone seems to have their own ideas. Everyone seems to have their own drives and their own pathways. Maybe there is a need to create that. So I suggest we could begin that activity. And of course, in governing all these, we need to have the autonomy and independence of everybody. But at the same time, it will be nice to have kind of an advisory governance that will guide this grandness of minerals R&D innovations and initiatives in the kingdom, articulate funding requirements and mechanisms, and will be facilitating all the partners, all the integrating that is required then. Because what needs to be done, and then through that governance, is coming up with the definition of those research programs that are of national interest, as well as coming up with programs of technology transfer and not having, for example, R&Ds that are for target technologies, ending for forever and not having, if you will, an outcome for commercialization later on. Of course, this is, I think I hinted this already, is the capacity building and training of people. It's most important. And I think I would advise to, in the beginning at least, to, in this coalescence of the effort for our that we interface with international collaborations, maybe through these mechanisms. MIAP already is being established, but it can also be established individual with the various research centers out there. At some point, all these needs to be revisited. So we establish these strategies. We need to meet at some point and actually articulate and redirect and refocus and reprioritize together with not only the research institutes and the knowledge generators, but of course with the industry, with the mind that needs to be on the table to make those decisions. And to be on board because it's of their interest as well. Okay, and so communication of all these issues is important then, because if everyone is informed about, aligned about, things can happen more easily, right? And I know I'm running out of time, but I have a case study of, I'm going to go very quickly through this, maybe 5 minutes. The intention is not to explain in detail, but just go to snippets of a programmer I worked with before, articulates all that I've mentioned, and then it's going to be at a high speed, so there's no detail. So this is the program, a CRC-OR encapsulated the optimization of these low-grade deposits and bringing technologies about it, right? We talk about how, in fact, the innovation progresses with all these stage gates and the TRLs, and how it comes to a point where there's a chasm or a death, is then in the middle, when the innovators, the guys that come up with the idea and the researchers are so excited about it, but then the industry, the miners, the doctors, they don't understand the technology and the whole thing drops down. And that's at that point, the research institutes and these bodies of R&D and the transfer of commercialization, innovation entities, they actually should be there to then uplift and hold that so it doesn't really drop, and actually pursue and demonstrate value further, do the piloting, do the demonstrations of value, do the business cases there at that point. Anyhow, so this is the explanation of where we progressed it. And then, what is this? Sorry, my Arabic is very rudimentary. So we, in this particular program, we actually involved the particularly people on the pipeline, and from the knowledge generation all the way to the implementation of these processes that we conducted, right? And what is now going? Not progressing. Sorry, it's going back. Is that way? Oh, this is in Arabic. Is the other way around? Sorry. Okay, so just so I was talking about partners and partnerships. Here's companies. Here's small mats companies that are supporting of the technologies and the gadgets and other research institutes. A similar body could actually, arrangement could be done in the kingdom, right? And here's what it should be about the entity, about improving, in this case was productivity, identify innovation, and then drive partnership models for delivering those. Because one thing is to create those research programs, create those initiatives of innovation, but then we have to create programs for delivering those as well, right? And so there's one mechanism of how we get involved with users of that. And is in fact how they played, what is the METs, the research groups, the miners playing a different stage of the TRL curve, right? So that's what the involvement. This needs to be articulated. Not everyone, the miners do not get involved in a phase of research, but they get involved later on implementation, right? So we need to, there are a number of programs. We articulate exactly what each program was, and what different research bodies on all those programs, okay? And there are a lot of universities involved in some of the definitions of those research entities. And the roles and responsibilities of each were defined, okay? And of course, characteristics of the requirements for the various stages were outlined. This needs to be, when I was talking about the governance of these things, is what I was talking about. And so the consortia then is developing amongst all these people that some contribute to the knowledge development, I contribute with the funds, I contribute the facilities, the miners contribute, for example, with the piloting sites and the other things. So it's a consortium that needs to be put together. The themes are generated for what is actually the project's entailing. And of course, this is sort of delivery schemes, how the progression of the technology development gets, in fact, into a delivery from the researchers to the trialing, to then the adoption, to the testing. So these needs to be articulated as an element, all right? So this is just examples of how we could carry out these engagements. It's a constant engagement with the industry, and there were workshops and collaborative and roadmap definitions and so forth that was involved. And also, of course, then you got the OEMs or the technology providers and the people that have got the hard technology on the side for which the researchers use to do the implementation. They need to be involved too, because the inputs actually that we develop in these R&Ds enable them the upliftment of their equipment capability, or even they can bring great inputs, insights to the research as well, right? So, and what else? I think that's pretty much it. Doesn't move anymore. So, but that was it. I think there's no more. Is it? There's no more to say other than those examples. Okay, that was the end of the presentation. So this articulation, then how we put everything together, mining companies, then the OEMs, to do then the delivery. Yes. Yeah, it was all involved, right? But of course, the various research bodies did components of that, right? So, for example, CAUS can do one component, CACS can do another one, but the integration of the program was key, right? I'll leave you with that. Oh, that's another thing that needs to be considered. When I forgot to mention is timing in R&D in mining is not short term, right? It's always long term, always long term. Of course, quick wins that we can get a project on the going for quick wins, but then normally it's a long term project, and the consortium needs to be committed to the long term investment of it. Thank you, everyone. Thank you very much for your attention, and I'm sorry that it started so late, and I really appreciate your patience.
Thank you, Dr. Fernando. It is our pleasure to have you here today. It was very insightful talk. We enjoyed having this exposure to the kingdom and Australia as well. And we have a couple of attendees from online and in person, and I want to open the floor for any questions. So if you allow me, just to start with the online, do you have any questions? Please raise your hand.